see friction in worm gears. The coefficient of friction in worm gear drives depends upon the rubbing speed. What do you mean by rubbing speed? Rubbing speed is the relative velocity between the worm and worm wheel. Velocity of sliding. In worm and worm gear drive, because of rolling and sliding, there is a friction, and because of this friction, there is a heat generation. And how this friction and rubbing speed is having a relation that we will see, and how it is helpful to decide the role of coefficient of friction in worm and worm gear drive. Velocity of sliding. Look at the figure. Now here, in this case, this is the worm which is shown by the hidden line. If it is at the bottom, and when this worm wheel which is meshes with this, the diagram is drawn in this fashion, which is below, this worm is below and worm gear is above, and its representation is shown here. V1 is the pitch line velocity of the worm, which is in meter per second, and V2 along the circumferential direction here of the worm wheel or a gear. Now here V2 of the pitch line velocity of the worm wheel, which is along the direction of rotation, Vs is the rubbing velocity in meter per second. The pitch line velocity of the worm is given by V1 is equal to pi dn upon 60. But here d1 is the PCD of the worm, n1 is the speed of the worm, and which is in meter per second. Look at this diagram or a velocity triangle. You will find this Vs. If you would like to resolve this component, you will get Vs is equal to geometric representation here. By using trigonometry, Vs is equal to V1 upon cos gamma. Gamma is the lead angle. Substituting the value of V1, you will get pi d1 n1 upon 60 into 1000 into cos gamma. Why here it is multiplied by 1000? Because it's in meter per second, otherwise d in mm. Now by using this sliding velocity, we can find out the coefficient of friction. Now here, in variation of coefficient of friction for worm gears are shown in this diagram. You will find as the rubbing speed increases, coefficient of friction decreases. And this plot which is constructed when worm gear is made of phosphor bronze and worm is made of cast hardened steel, which is lubricated with mineral oil having viscosity 16 to 130 centistokes at 60 degrees Celsius. By using this chart or a graph, we can easily find out the coefficient of friction for different rubbing velocities, and this value will help you to get the efficiency of the worm and worm gear drive. Now efficiency of the worm gear drive, generally it is given by power output upon power input. Now here power output or output torque or the one which is given P2T into D2. In this case, worm wheel or worm gear is mounted on the output shaft. That's why tangential load on worm gear which is taken into D2 by 2. This is nothing but a output torque or a worm gear torque. And P1T into D1 by D2 is the input torque on a worm. P1T is a tangential force which is acting on the worm, and D1 is the PCD of the worm, where it is this torque is multiplied by air speed. N2 is the worm gear speed and N1 is the worm speed. So you will get efficiency, that is power output upon power input, or in other way you can write force into V for worm gear and force into V for worm. By using this expression we can find out the efficiency of the worm gear drive. But we know that the gear ratio in case of worm gear drive, that is N1 upon N2 is equal to I. Rearranging this equation, N2 upon N1, you will get 1 upon I. N2 is the speed of the worm gear and N1 is the speed of the worm. From this expression you will get N2 upon N1 is equal to 1 by I, and this is arrangement is made to substitute this value in equation of efficiency or A. Further we know that D2 is the pitch circle diameter of the worm gear, which is given by MZ2. M is the module and Z2 means number of teeth on worm gear. And D1 is the PCD of the worm, which is given by M into Q. Now we are substituting the value of D2 and D1, we will get Z2 by Q. Arranging the terms, dividing both here by Z1, Z2 by Z1 upon Q by Z1, you will get the value that is equal to I upon 1 upon tan gamma. And here making the arrangement of equation, you will get I into tan of gamma. This is equation number C, as tan gamma is equal to Z1 upon Q. Further, by substituting these values of D2 by D1 is equal to I tan gamma and I is equal to, that is N1 by N2, or N2 by N1 is equal to 1 by I, we can write the equation efficiency is equal to P2T upon P1T into tan gamma. Now here tangential force on worm gear is nothing but a axial force of the worm, and substituting it P1A upon P1T into tan gamma, we will get here again axial component of the worm and tangential component of the worm. We have already seen in force analysis of worm gear drive. Substituting this value of P1A here, that is cos alpha cos gamma minus mu sin gamma. Alpha is the normal pressure angle, gamma is the lead angle, and mu is the coefficient of friction, upon the value of P1T cos alpha into sin gamma plus mu cos gamma. And now here these equations obtained from the resultant reactions of the forces in force analysis plus frictional forces, they are superimposing these values, we have obtained the resultant forces on the worm and worm gear. By substituting these values, we can obtain efficiency is equal to, this is final expression, cos alpha minus mu tan gamma upon cos alpha plus mu cot gamma. By using this expression, we can easily find out efficiency of the worm gear drive. Now here in worm gear drive, we are aware of that worm is always driver and worm wheel is the driven member. And reverse motion is not possible. This is called self-locking drive. Because of this, the worm wheel cannot drive the worm. As for screw threads, the criteria for self-locking is the relationship between coefficient of friction and lead angle. In case of worm gear drive, we can say worm gear drive is a self-locking drive if coefficient of friction is greater than tangent of lead angle. The friction angle is more than the, but this is the condition for self-locking, and this condition is used in material handling devices or lifting of the material in industrial application for worm gear drive. There is another term, reversible overrunning or back driving worm gear drive. Generally, this condition is not used in worm gear drive or it is not prepared. But in some of the applications, if the driven machinery has a large inertia and if the driving power supply is cut off suddenly, the worm is freely driven by the worm wheel. This prevents damage to the drive and source of the power. and worm gear drive is said to be irreversible if coefficient of friction is less than tangent of lead angle or friction angle is less than the lead angle. The same condition which is we are already studied in power screw, that is mu is less than tan gamma. From this topic we have learned the relation between the coefficient of friction, rubbing speed, velocity, a sliding velocity, and how efficiency depends on coefficient of friction and rubbing speed and its importance in worm gear design.